Okay, welcome back. Thanks for joining this, our final segment of the Automation Summit. Hope you enjoyed our client panel earlier today, as well as Johnny and Ryan's sessions on automation and observability. If you missed them, they'll be available on demand at the conclusion of today's event. We'll start off our final segment with Tim Curlis, one of our leading cloud and DevOps thinkers at AHEAD. Tim's going to discuss how GitOps and automation can bring unparalleled speed and consistency to CI/CD tool chains. Very important session. Then we'll wrap up our summit with a session that kind of brings it all together, led by Chief Cloud Architect Nick Collier on the concept of an automation hub and the important role it plays in managing automation at scale. We've also added a fun, kind of entertaining, lighthearted session we added just for you, our participants, beginning at 3:30 Eastern Time, called Derby Day, Place Your Bets, featuring horse racing expert Jody Demling. If you're interested in the upcoming Kentucky Derby, maybe going to put down a wager or two, be sure to attend. As a reminder, please submit questions by clicking the QA icon underneath the video console. Each speaker will take questions at the end of their session. And please visit our sponsor booths to get some really informative content and win some cool prizes. Speaking of those prizes, again, if you fill out our feedback survey, another icon on your console, you'll be entered to win one of 5 AirPod Max over-the-ear headphones. And we would, of course, always love to get your feedback. So, thanks again for attending this year's Spring Summit. Please ask questions, and with that, I'm going to turn it over to AHEAD's Tim Curlis. Tim, take it away.
Thanks, Tom. So let's get into this and talk about how we can do GitOps for all. First of all, why are we here and why is GitOps going to help us? So these are things we've noticed as we've worked with our customers, especially in recent 6 to 12 months. Lots of novelty, lots of choice, particularly in the areas of cloud native and containers. And it's very inspiring and it's great for individual and team innovation, but it needs channeling in the enterprise to increase business innovation and outcomes and really achieve operational excellence to get that business advantage. Some key observations we've made: individuals and small teams are getting this and they're moving fast, but the overall business of IT is not. It's not scaling as well as it could. And I think the amount of choice is really contributing to that, as is the newness of it. Backlogs, therefore, and technical debt are piling up. And automation is great. It is occurring, but it's happening in silos. And so silos are optimizing their processes really nicely, but are not yet really achieving scale and connecting that across the different groups within IT to really create that business value. And really, they're, because of that, or as part of that, deployment or development, operations, and security are still kind of struggling to work together. The lines are starting to blur, but it's still in its early stages, I would say. So GitOps was created by Weaveworks, and it's been transitioned to an autonomous working group. But it's really a model for scaling cloud-native platforms and development, relying on really repeatable patterns to enhance that operational excellence. So let's get into how and how that's going to happen with really the 4 principles of GitOps. So the first principle is that everything, the entire system, is described declaratively. So we'll get into what that means. But the system needs to be described declaratively in terms of what it looks like and how people refer to it. Everything needs to be versioned, and the desired state needs to be versioned. Typically in a Git tool, it can be GitHub, GitLab, Bitbucket, but it needs to be Git flavored just to be able to adopt versioning and the branching strategies. Thirdly, automation is part and parcel throughout. Approved changes can be automatically applied to the system, so we'll talk about that. And fourth, self-healing. So software agents exist in the system to ensure correctness. Again, because we're in a declarative state, we can look at the divergence between reality and what our state should be and use agents to correct that. So let's talk more about the first principle, that the entire system is described declaratively. That means it's self-documenting, it's immutable, and most importantly, it's deterministic. We know what the outcome is going to be, and it's idempotent. So some themes that we see, again, declarative versus imperative. So look at that as, in the case of a map or giving directions. If I'm standing there and I have to understand where the person starts and then tell them to turn left on First Street, turn right on Main Street, and you'll get to the Apple Store, right? That's a stepwise imperative set of instructions. Declarative, I would say, open Apple Maps, type in the Apple Store, and hit go. And it doesn't matter where you are, it will guide you to that. That's what we're really looking for as part of the first principle of GitOps. So everything is stored in Git. Everything is rapidly restorable and can be rolled back because of that declarative nature and how it's versioned. So some example tools, and trust me, there are many, many, many more than this, but I think if we look at them as categorical, infrastructure as code, so tools like Terraform, very declarative, very much fitting into this model, as well as configuration management tools like Puppet, Ansible, things like that. And really Kubernetes itself, has, by its nature, is very declarative. So some user stories, it's things like defining configuration, using tools like Kustomize and Helm, so we'll see that. Immutability, gold images, and not just container images, but it could be VM templates, environments that are fully templatized so that I can give developers environments on demand, and just really infrastructure as code in general. These are all really important things that we're seeing and big movements we're seeing in the business right now. So getting into some demos, I, of course, bit off way more than I can chew, and I have about 8 demos here, but only time to show 3 of them. So the remaining 5, with the watermarks in the upper right corner, you'll see, will be featured on the additional resources after the sessions are over, and we'll guide you to a separate web page that will have basically video recordings on demand of all the demos, but especially the ones that are pictured here but not played, so are not demoed. So to that end, our first demo is environments on demand. So why do we see this and need this? And the concept is that developers just want to get started writing code. They don't want to have an environment that they have to install their database, their middleware, et cetera. They just want to open up and start writing code. And operators want to make that request process and have a platform that's easy. So using a service portal like ServiceNow in our automation hub, we're able to give the developers a few choices of what they need, specify that in the form, and then have orchestration declaratively go through and spin up not just a set of servers, but it could be a totally new operating environment, say Kubernetes in a cloud environment. It can provision shared services and access to things like Consul and Vault. It can set up testing tools. It can set up monitoring tools, and it can really stage the landscape in the CMDB in ServiceNow. So there's a whole host of things that we do and we sort of orchestrate so that really that developer can just get started. So that's the first thing, is environments on demand. And like I said, check that video out after the session at the additional resources. Secondly, a demonstration following part of the first principle of GitOps and being declarative is the idea of building golden images. And it's really the why is because we want a consistent build process because that's easier to secure and easier to maintain. So rather than have developers write their own Docker files that can all be different and get source images from different places, we're going to make a factory approach and use Tanzu build service to do some very declarative automation around taking our microservice on the demonstration. We're using our fuel service, which is part of our head aviation landscape. The airplanes, when they land, there's a fuel service where they can order fuel for the next flight. So this is just a small microservice written in Go. And it's coupled with base images from buildpacks.io, as you'll see in a minute here as part of the demo. And the idea is to automate this whole process of building and produce these OCI compliant images that are very standard across the organization. And I can specify kind of strictures and ground rules that get everyone off to the same start and also make things easier to secure. So let's take a look at that right now. In this demo, we're going to look at how to build golden images with Tanzu Build Service. Tanzu Build Service, once again, is an enterprise-supported implementation of open source concepts. So let's get into this and look here. First, in our Kubernetes cluster that we've seen previously, we're going to switch to the KPAC namespace. So KPAC is the open source orchestrator that is supported as part of the enterprise Tanzu Build Service. And as we switch to this namespace and look at, we'll just do a kube control get all, and this will show some of the pieces that are installed with the build service. So you can see it's fairly straightforward. It's essentially a controller that is going to orchestrate spinning up pods in order to do steps of the orchestration process, as well as a webhook that is going to, by default, listen for any repositories that are referred to in images for any changes that would necessitate rebuilding that image. And then we'll see how that works in a moment here. And in addition, if we look at our API resources, and I'll just grab this out by KPAC, you can see some of the stuff that Tanzu Build Service installs into the cluster. If I could spell properly, include what you'll see here. So there's things like builders. Which essentially cluster builders or builders are an amalgamation of stacks and stores. And what a stack does is essentially include a build image that we're going to use to build our container image, and a run image that we're actually going to use when the image runs. And the difference, of course, is that the builder requires typically a lot more dependencies that really inflate the size of that image. And so from an efficiency standpoint, we want to strip all of that out. A great example is that when you're building a Java image, you need the JDK to do the build, but you only need a JRE to run the image, right? And so we want the run image to be streamlined and thus make the final stored image a lot smaller. And then stores are simply storing the cloud native build packs that are available to use here. So if we sort of look, the first thing I want to look at, the last one here is images. And images are the actual container images that we're building. And they're defined, again, they're defined declaratively and stored as code. So within my ops repository for my fuel service that we have here, I'm going to go ahead and just do, so you see here, first of all, the image is stored as YAML. And then I'll go ahead and just do just look at the YAML itself for that fuel service image. So, a few things to pick out here. Defining this obviously as code. First of all, the builder we're just going to use the default cluster builder. We've got some caching involved, so Tanzu build service helps optimize the caching involved with building images so that subsequent builds that, parts that don't change will be a lot faster. And also we will use a lot less storage on our clusters. You can see the source. In this case, we're not pointing to a Docker file, we're pointing to our code, right? And so within FieldOps, I have a microservice called Fuel Service that I simply point the folder, and this process will look into that folder and recognize, hey, this is a Golang application. I know what I need to do to build that. From a version standpoint, we're using a specific git commit ID in order to make this process, very deterministic, and we'll see how this is used in a future demo here. You could certainly specify a branch here. You could do this on master, on dev, and essentially, if you specify a branch here, the watcher is going to rebuild this image every time a new commit comes into that branch, which may or may not be what you want. So in this case, we're opting to use the specific commit ID. And then an output, right? So we have the source is the code in Git. The output is, in this case, a image tagged head aviation / fuel service with a version, and then it's going to subsequently tag that with the actual build number. And before we go ahead and run this, let's just look at a couple other things. So we're going to switch to our shared services namespace here, and we're going to go ahead and do just keep control get secrets. Because obviously what this is going to need, if we look here, is a secret credential stored with access to the repository, in this case Docker Hub, as well as the incoming source from GitHub or your Git repository. So this would be a great opportunity to integrate with Vault to store these, because they are secrets that we're going to you create API keys and want to definitely store those as secrets. In addition, here we can use the KP CLI, which is part of Tanzu build service, and we can look at our cluster builder. In this case, as we saw previously, we're using the default cluster builder, so we'll go ahead and get status on default, and we'll see that these are all of the build packs available to us, and this in particular is the run image, and this is stored again in our Docker Hub or whatever registry you'd like to use, and it's based on the Bionic image, which is a form of Ubuntu. And then from the build pack perspective, you can see plenty of options here relating to all of the kind of common classifications, so .NET Core, Golang, Python, Nginx, Node.js, and Java, of course. And the interesting thing is the detection order here. So this is the list in order that it's going to go through when it's trying to analyze the code. So in order to optimize things and make it go faster, we could create a custom builder where we move, if we do a lot of Go development, for example, we could put this at the top, right? And so then it'll short circuit out and not have to analyze all these other language frameworks. And so that is to say, you can certainly customize and do your own builder. And if you didn't trust these particular build packs and you wanted to use your own or use a different hardened registry, not that this isn't hardened, you could certainly do that as well. And then so if we look also at the builder itself is, like I said, a form of combination of the stack, right? So the stacks involved here, cluster stack list. So you can see the default one, it is using this stack, which again, the stack is comprised of the build image and the run image. So you can create a custom stack if you want to specify your own builder image, for example. So let's go ahead and just do kube control apply the fuel service image. Fuel service image.yaml, I believe I called it. Great. Okay. So now if we look at kgit images, we'll see that we've got the image created here, and it's currently unknown because it was just created. So one thing we can also do here is just do a KP build list. So when an image is first created, it is going to immediately try to build it. So we do see that build number 1, and it's currently building because we just defined this and it kicked off. And whenever you see the reason is config, that means that something changed on the incoming Git repository that would necessitate a rebuild. If you use Tanzu build service to rebase, as it's called, so I want to change just the underlying Ubuntu piece or the Go piece without my app code changing, that would be a reason called rebase, where I'm sliding out one of the bottom layers and I'm improving or fixing that without rebuilding the entire thing. And then the other thing we can do here is just do the build logs, so the fuel service. And what we'll see here is the ongoing graph. So we prepare by cloning this resource. We can see it found that revision at this URL. It's going to load the secret, like I said, for both Docker Hub and GitHub. Successfully clone this. So now we do the detect stage. And again, it's looking at the files, and based on the directory and file structure, it says, I recognize this. This is a Go application. If it found a maven.pom, it would say, oh, this is a Java application, etc. We'll do an analyze, so if we have cache data that we can use, we'll restore that. And in this case, we did not because we just freshly defined this. And then we'll do our initial build. So it's going to say, okay, we're going to select the Go build pack. Here's the version I'm using that I get from Cloud Native Build Packs. I can see this is based on Go 1.16, and then I start to do the things you'd expect in a kind of Docker file approach, load my dependencies and do the actual build. And it even shows, this is the Go build command, or if you were doing Java, the Maven build command, Gradle build command. And the build tells us it's successful. So now we're going to go ahead and export this. It is able to reuse some layers because they're based on something common to the cluster already. And eventually we spit out a OCI compliant image which has this SHA. Here's our tag, and subsequent additional builder ideas added there as well for uniqueness. And finally, we can see this build was successful. So if we list our builds again, we should see success here. Great, and this is the image that was created. So we're again pointing to Docker Hub. Let's just go ahead and jump over, and we can see here's the repository. I'll just do a refresh. And here we are. 2 minutes ago, we had a version that was pushed. And the tag should match unless it was cached, because I've been testing this. So 2021 422. Yes. So here it is right here. Right here. Yeah, 2 minutes ago. So here we can see this is the image, and obviously the registry does its thing if it scans it or what have you. But at this point, we can see that Tanzu build service went ahead, and rather than us creating a Docker file, it figured out how to make an enterprise fully orchestrated build of an OCI compliant image and pushed it into Docker Hub. All right, so our next tenet is that the canonical desired state should be versioned in Git, right? So Git is our single source of truth. So some of the themes, there's always questions around, should my app code be stored with my ops code? So there's trade-offs, right? Sometimes it makes sense to locate them together. Other times we might want to separate them. And a lot of times in this demo, you'll see us separate them just because then we have different life cycles, we have different access depending on the teams working on it. Really it's based on, if changes the infrastructure might not change the app and vice versa. So it can kind of make sense in our opinion to do it that way. Example tools, obviously it's all Git here, but I think, there are things that sort of flow and follow from that. Things like Helm charts that we'll see an example of actually Kustomize here in a moment. But, the point here is we're using some Git-based tooling, whether it's Azure DevOps or GitLab or Bitbucket. Things, the user scenarios that we care about, storing configuration as code, doing deployment logic really around our SDLC, so our classical sense of having to wait for dev environments to be refreshed or provisioned and flow through to test. I mean, all of that is versioned so it can happen more automatically. So let's look at a couple of demos here in terms of what this looks like. So first, we'll do a deployment with Kustomize. This is a deployment to Kubernetes. And the challenge is that we'll write these Kubernetes manifests, but if we're going to dev, test, stage, prod, et cetera, a lot of times there's really high levels of code duplication. So Kustomize is a way that we can create a base set of uniform code that applies to all environments and then overlay or merge changes for dev, for example, and then different changes for prod based on what we need. And all of that is stored in this ops repo. And so we're going to see how Kustomize helps us manage configuration as code.
In this demo, we're going to show how Kustomize can be used to create declarative versioned configurations to deploy your applications, in this case, our fuel service microservice. Here we have the folder in the GitOps repo, our ops repo for the fuel service, where we're storing just our Kustomize and our Kubernetes manifests. So first, we'll just take a look at this folder, and we'll see Kustomize employs the concept of a base and overlays. So in the base, we have our typical manifests that are common code between any prod, dev, test, stage, etc. And then overlays overlay specific environment configurations for each. So basically, the changes that we want to employ in each of these environments. And if we just take a look, first we'll just take a look at the base. Mike, you see the base deployment for this. You see the fuel service itself. The image we're going to run, one replica, pretty basic stuff. And if we look at the overlays, you see, so in production, for example, we specify a customization.yaml file that says use the base deployment and service, but in prod we want to change the namespace to use the prod namespace, and we want to prefix all of our resources with the prod dash prefix. And then you'll see that we also want to merge in some additional configurations, in this case this healthcheck.yaml, which is nothing more than, in this case, just wanting to add some liveness and readiness probes to our application that wasn't part of the development workflow. So now we have this, we can actually go ahead and we'll go into the prod folder, and we'll also create the namespace for prod, because I don't believe it exists yet. And then we'll switch to that namespace prod. Okay, and we'll see it's empty. Great. And so now what we can do is use Kustomize to generate a build, load restrictor none, in this folder. And what this is going to do is actually render the manifest template based on our base service and deployment with the changes we wanted merged in, so the health, liveness, and readiness probe that we saw. And if we actually just send this exact same thing straight into kubectl apply, we'll see this rendered and then applied to the actual cluster. Great, and this is declarative. So now that we have that, we'll go ahead and do a get all. And at this point, we can see the deployment was created, container's already running, and we have a service deployed. Well, in future demos, we'll go through how to automate the actual deployment, but you can see just from a hands-on perspective how we can author our Kustomize YAML code and have this deploy customized changes for different environments that does not require us to reuse common code.
So our second demo is coming soon on our follow-up resources. The sense of deploying an app, right, you just saw in Kubernetes, it's not the only thing we version. We can version infrastructure as code and infrastructure changes as well, and configuration changes. So in this case, our fuel service actually leverages Consul for all of its configuration data, and it leverages Vault for its secrets to connect to the database, et cetera. And what we can do is, using the automation within Consul and a tool called Consul template, is we can actually watch for any configuration changes based on updates that might occur. Maybe a great example is, you'll see in the demo, is say the user password credentials or the host address for the database change. We can go ahead and update that in our canonical store, which is Consul and Git, and it will automatically detect that change and determine that it's out of sync with the desired state. And we'll go ahead and basically refresh from Consul and restart the app service without somebody having to put in a ticket, without having to take downtime and manually restart the application. So that will be available in the supplemental resources. Check that one out. So third principle is, again, the principle of automation. So approved changes can be automatically applied to the system. And I want to point out, this doesn't mean that every change just goes through. It just means that we have to get through approvals first. And that may be a manual approval to start with, but we should get to the point where it's a fully automated approval system based on a series of tests that you run. So it could be smoke tests, regression tests, et cetera, as well as passing something like a ServiceNow standard change. So is this in the right change window time of day? Is the system currently functioning per the CMDB, right? So we can do things like, if the system is currently having problems, then we're not going to automatically apply changes. So all of this stuff, is part of automation. And some of the themes, again, it's very declarative. And it's this idea that CI does a build, but it needs to evolve to full CD, continuous deployment, so that we actually apply what new builds happen to the system itself. And really, we see a great potential for ESM integration here, so integrating with ServiceNow. Developers, it's not fun as a developer to have to stop and enter a bunch of data into ServiceNow. But conversely, the business needs that information. So we want to use automation to drive that information back and forth. In the session you just saw from my colleagues, Ryan Hale and Johnny Hatch, really highlight what we mean there. And we're happy to talk more about what that means. But some example tools in this space, you're going to see the demo Harness and Tecton from a CI and CD perspective. And then, of course, tools like Jenkins X and CloudBees. And then a new tool from HashiCorp called Waypoint that we're very excited about. It's very early and it's evolving, but tools that can automate some of these build and deploy processes. Scenarios that we'll look at are build and test automation and having templates and test harnesses, and doing pull-based deployments, not just from a change in Git, but Git causing a new artifact and then pulling from that artifact source. And of course, infrastructure changes, right? When something happens in the system, we want to correct that, and you'll see that coming up as well. So looking at the demos, we've got another demo in the supplemental resources around continuous integration. And we're using a tool called Tecton, which is a native pipelining tool within Kubernetes itself, or that we can run on Kubernetes. This could very easily be Jenkins pipelines. It could be GitLab CI pipelines. It could be Azure DevOps pipelines. But the point is, it's something that is becoming a very common pattern where we go from a new commit to source through a series of tests to build a new image and store it in some artifact repository. Could be Artifactory, could be Harbor, could be GCR. And the point is, this is taking the source of the code, commit change to an artifact. So you'll see in the demonstration, we go through the different pipeline stages, the execution of that, and how the interplay between the apt repo and the opt repo really drives that and helps us understand when we need to do a test, how can we interleave deployments to test environments, and really tighten that up, into a very robust and very dependable, reliable process. So check that one out. And next, we'll see taking from continuous integration. So now we've built a new artifact based on a change to source to continuous deployment. So based on that artifact store as an input, how can we get that artifact deployed to our environment? So we're going to see a harness pipeline that even broadly deploys to dev and then to test, does some tests to do an approval, and then deploys to prod. And going back to our Kustomize demo, this process doesn't reinvent the wheel. It uses that Kustomize, as we saw, but it automates the process of applying it. So let's go ahead and take a look at that now.
In this demo, we'll walk through a fully automated CD deployment using Harness. Okay, so what we can see here is the Harness main dashboard, and I'm going to walk through first the setup of our field ops microservices application. So if I go into setup here, I can see there's a number of elements that I need to work through as I set up, but for the most part, they move top to bottom, left to right. So we'll look at services first. The number of services here would be more, so field ops has other services, other microservices. We're just focused on fuel service at the moment, but say you had 4 or 5 microservices, they would each be a service here. So if we drill into the fuel service, we'll see that the service is based on an artifact type of a Docker image, and it is coming from a source based on the repository that we've seen in previous demos on Docker Hub. So that's one important distinction here, is that the trigger is not a git commit. The trigger is a new artifact. And if we look at what this job is actually doing, there's a number of ways to set this up. But we're actually configuring this to pull the operations repo, the GitOps repo, and use the directory to the customization overlay for the environment name, and note we're using a variable here, a templatized variable, so that we can reuse this code. So what this is going to do is this service is going to be based on an artifact from Docker Hub, and the deployment is going to use the Kustomize capabilities from the source repository, as we've seen in previous demos. And one cool thing to note is I'm using the GUI at this moment, but everything in Harness, per our discussion around GitOps and everything as code, everything is in this system as code as well. So I am able to do all of this work as YAML and follow the same kind of GitOps principles that we've been following so far. So now that we have our service, we'll go back, and the next thing we need to think about are environments. So one thing about CD is that we really want to focus on this abstraction between what we're deploying and where we're deploying it, so that we can templatize and override and overlay different environments. So I've got my two environments set up here. You see dev and prod, and these are based on the GKE cluster we've seen in previous demos. And so what I'm doing is I'm using a very simple Harness agent that's running in a pod in the cluster to orchestrate this whole process. So this infrastructure definition is pointing to my cluster via the Harness delegate. And I simply specify the same cluster, but I can override and give it a different namespace. So for the dev environment, I'm saying this is not production. I'm saying use the namespace called dev. And likewise for production, I am specifying the same delegate, but I'm specifying the namespace of prod. And there's a number of things we can add and enhance this with in terms of overriding various service configurations, as well as setting up 24/7 monitoring using the tools like Datadog and New Relic, AppDynamics, etc. So now that we have our service and our environment, we need a workflow that will combine the two. And as you'll see, going back into this, the workflows comes next. So I've got a workflow called deploy API, and the first thing you'll want to note is that this doesn't have a specific pin to what we're deploying and where we're deploying it. It once again uses templatized variables. So as we kick off a deployment of this, you can see that the service is variables is using the variable service, and the environment is using the variable environment. So if you were to click deploy here, you would see it's going to ask, what do you want to use, dev or prod, which service are we deploying, in this case fuel service, and which infrastructure definition should I use. And this would work, and I could fetch the artifact, etc. This would be for a manual deployment. So let's look at what this workflow is actually doing. You can see here the workflow type is rolling. There's many workflow types. I can do things such as blue-green. I can do things such as canary, etc. In this case, I'm keeping it simple with a Kubernetes rolling deployment. So the deployment step, you can see first I actually want to execute this templatized script to run Sonar Cloud to basically inspect the new artifact and then make sure that what was built, just another step there for security is, make sure everything's looking good. You could do unit testing here. You could do all sorts of things before the deployment. And then we have the actual deployment itself, which again is using Kustomize that we've seen previously. So it's automating that manual process of doing the Kustomize build and rollout. And then lastly, we've got a simple health check. You can do all manner of things in here. Wrap up could take care of removing, infrastructure that you no longer needed, et cetera. So all kinds of things you can do in terms of adding additional steps and changing the order of steps. And if you look at steps, we have also application templates as well as a template library. So if you had teams, that all wanted to use Sonar Cloud, there's no need for them to each write their own script. We can write one, store it in the template library, and reuse it over and over. And again, this links to the template, which once again is stored as code. So the code is very shareable, very storable, and follows the GitOps tenets. So now that we've seen the service that we're deploying, the environment that we're deploying it to, and the workflow that does the deployment, we can sort of zoom out one more click to a pipeline. And a pipeline will take on multiple workflows to create some higher order service. So the CD workflow that we saw that we want to create this pipeline around is to deploy to dev, then to run some additional full suite integration tests, maybe do an deployment with an approval with ServiceNow, and finally to automatically deploy to prod. So as we saw in the third tenant, approved changes are automatically deployed. And once again, this isn't to say that anything goes through willy-nilly. It means that we're going to really architect our approvals in the form of scripted checks, integration testing tools, suites, harnesses, and various automated approval steps. So this is the full pipeline that gets executed, and obviously if some approval doesn't go through, the tests fail, we're not going to fully deploy to prod. And there are various points in here that will roll back automatically as well. So now that we have the service we're deploying, the environments, the workflow that gets it done, and then the pipeline that links everything together, the last thing we'll look at here is just triggers. So once again, the distinction here is this is not triggered on new code. That's for the CI process. But that CI process will, based on a new code commit, will build an artifact and place it into Docker Hub. So the impetus for this CD process is actually triggered based on a new artifact being present. So you'll see the trigger here is simply the source is pointing to, again, that Docker Hub repo looking for the fuel service. And in particular, we are specifying a given tag, and this isn't shown here. Let's see if I can get it up. There we go. So the condition is to use this tag filter, so I can use regular expressions. And this, this was something you could update using, a CD or CI deployment process. So when a new build happens, the Tecton subsequent pipeline will go in here and update this to an exact build number so that you can be very, very deterministic. I'm just here using the nomenclature around our Tanzu build service. We know that a build is going to begin with B. So this is a little bit overly permissive, but works in the case of our demo. So now that we've seen the full pipeline, let's go ahead and let's just once again use Tanzu build service just to trigger that image build. So I'll just do a KP image trigger fuel service. And now if we look at the build list, we'll see we've got build number 4 here. It's currently building. The reason for building is based on a trigger. We're not going to look at the logs. We saw that in a previous demo, but suffice it to say the caching should take care of this pretty quickly. So let's hop over to our Docker Hub, and we should see here momentarily a new image is pushed. And that was the 4th build, so you can see here build 1, 2, and then here's build 3. So within just a moment here, we should see build 4. And while that's happening, we can think about, once again, that all of this follows the GitOps principles because it's all based on code and it's all based on YAML. And so very templatized and very easy to share across teams. I think that might be down here now. Oops. So here we have build 4 a few seconds ago. So we have for sure a new image in the registry. So if we go back to Harness and we just head back to our deployments dashboard here, we should see a new one kicking off. Sometimes it can take 5 to 30 seconds or so. Here it is. So the pipeline is kicked off. So the trigger will trigger a pipeline run. It can trigger single workflows and things like that. But you can see it's going through. It's deployed to dev successfully. It rather quickly did some integration tests. Certainly in the real world that would probably take longer. I'm going to manually approve this ServiceNow, but this could easily be done in ServiceNow as a standard change if it meets a set of criteria. So following that, you can see we've deployed to prod here, and everything looks good. It's going to do some post-deployment and verify, and there we are, success across the entire pipeline. And if we just go back here, we'll go ahead and just do a k-git pods in the dev namespace, and we should see that there we are, the fuel service. Didn't replace that because it knows that it's not a changed, there's no app changes, so the pod just continues running, but prod should be running as well, and you can see that one's been running for 12 minutes. So once again, we've fully automated not just the building of a container, but all the way to deploying that new application to our Kubernetes cluster using Harness. And lastly, I'll just mention, we've shown a lot of Kubernetes, but Harness is also capable of doing standard virtual machines and various infrastructure pieces, both in the data center on premises as well as in the cloud. So massive potential in terms of what we can link together for complex application deployments. Hopefully you found that helpful, and thanks for watching.
All right, so our last tenet here is around self-healing. So again, software agents ensuring correctness and alerting on divergence when reality doesn't match that desired state. So instrumentation is really what brings together the teams, right? We have tools that Johnny and Ryan showed that bring dev and ops and security together, but we want to protect not only the code and the artifacts, but also the runtime itself, and really enable our developers to be choosing the right tools. So here we see, tools from Tanzu, things like New Relic and Datadog, really coming together to instrument the entire system. Scenarios that we're looking for are observability and service graphs, understanding dependency mapping, because these systems get quite complex, automating infrastructure updates, and really having a problem, instead of emailing or paging someone, having it trigger auto remediation. From a demo sense, both of these are going to be follow-ups on the extra resources. So first we have application changes, configure infrastructure changes using Consul Terraform automation. So a new service comes alive in Kubernetes. Consul, as service discovery, sees that, and it tells Terraform, hey, I need you to update the firewall rules. So Terraform modifies Palo Alto, and the system within Azure, in this case, as a whole, is really orchestrated based on that app change, but is fully self-healing. So check that one out. And then lastly is, continuous operations, right, which I look at as increasing your sleep at night factor, right? And so Harness and Kubernetes work together here with tools like Datadog, New Relic, to really, look at the system and find if something no longer matches what's expected. And again, rather than emailing and paging, let's use these tools to automatically trigger the orchestration and automation that we've created, right, and gain more economies of scale there. So we've gone through the 4 principles of GitOps, again, declarative, system, version, and Git, prove changes applied automatically, and agents ensuring self-healing and correctness. So some quick takeaways, benefits. Obviously this is great for teams, really brings the teams together and helps with enterprise scale. It certainly helps move faster with rollback, is very self-documenting, takes advantage of automation. But some limitations, this is an emerging technology and is progressing and maturing. There's some upfront complexity in training. There's a potential kind of support for legacy systems. This clearly works well in a cloud-native Kubernetes model, but there is things you can do, certainly with virtual machines, networking, infrastructure, et cetera. And it's all about finding those creative solutions and applying these principles to that pattern to understand it. It does require some stitching, and that's what we're here to help with. And then things like visibility need to be addressed because you're automating a lot across these systems. So again, this has been GitOps for All, and hopefully this was helpful. So thank you for watching, and we'll go ahead and transition to the Q&A session right now. Thank you.
All right, and of course, I didn't leave a ton of time for questions, but I think we can squeeze 1 or 2 in. I'll also, as you heard, have additional demos coming up soon here on the additional resources and the ability to kind of answer questions there as well. So, one question coming up here, just I get this one a lot, is you see Kubernetes in the demos. How do we get started if we're not using Kubernetes, or more appropriately, if we have a lot of other applications? I think it's important, first and foremost, to understand the process you're going through and where the manual steps are today, and then use that process to really identify priorities for automation. But as you'll see in some of the additional videos, these are things we can do with virtual machines as well as infrastructure such as firewalls, load balancers, utilizing infrastructure as code. So the GitOps process, in this case, can change rules on a load balancer, or can change rules on a firewall. Things that more traditionally happen in the VM space as well. And just as the environments on demand, I think as we're provisioning development environments, that stuff is things we can templatize using tools like Packer from HashiCorp if it is VM related, and then really orchestrating still getting those development environments spun up. So lots of potential, not just in Kubernetes. And lastly, quickly, question, what is the lifespan, in my experience, for a specific tool in this space? I think it's a great question because, this is an area that is changing very rapidly. So, again, I think it's important to have, the process in mind, but also we look at kind of creating an internal product based on the solutions that you stitch together. And then as such, you can have kind of a roadmap around that and have a feature roadmap, right? So if a particular tool is something that's on the way out and you need to replace that, there's a process there, kind of like product management, that you can ingrain that and sort of retire the old process without really impacting, the outcomes of that overall GitOps process that you've stitched together. So, that's kind of the one thing I would look towards, as a holistic product versus just individual tools that you have to continuously manage. So that's about all the time we have. I just want to mention, again, fill out the survey. We've got a few AirPod Maxes to give away there. Make sure you do stop by the sponsor booth. A lot of the tools that you saw today, we have, the sponsors, or the manufacturers and creators of those tools can certainly show you more advanced use cases that dive in deeper. And then lastly, just like to go ahead and introduce my colleague, Nick Collier, who will be talking in the next session about the AHEAD Automation Hub. So thank you for attending, and I hope you enjoy.